For the first problem, we were asked to take the 150 kilogram bumper car and it runs into a wall at 4 meters per second and then bounces back at 3 meters per second. So I showed my motion map as moving at a constant acceleration and then bouncing back and constantly slowing down. For the second part of the problem, we were asked to find the change in momentum. So I used the formula change in momentum equals mass times change in velocity. So I did 150 kilograms times negative 3 meters per second minus 4 meters per second because it's negative because it's bouncing back. And then I got 150 kilograms times negative 7 meters per second. I got negative 1,050 kilograms meters per second. For the third part of the problem, the question is, can the car in contact with the wall for 6.0 times 10 to the negative third seconds, what is the average force exerted on the car during the collision? So I did force equals change in time equals change in momentum. So then I divided that by change in time because we're trying to find the force. So I did negative 1,050 kilogram meters per second divided by 0.006 seconds, and I got negative 175,000 newtons. And for the final part of the problem, it said the force on the car versus the force on the wall. And I said Newton's third law says that for every action, there's an equal and opposite reaction, making the forces the same size but in opposite directions. Airbags and crumple zones make cars safer because it increases the total time of impact, which in turn increases the impulse of the crash. Higher impulse equals the less damage done to the person. Greater time equals greater impulse equals lower momentum. This question asked what the final velocity of the canoe was, so I took the masses and I added them together, and the equation was mass, the initial mass plus the second initial mass equals the final mass. And so I did 195 kilograms times 0 meters per second plus 5 meters per second equals 200 kilograms times x meters per second. So I got 0 kilograms meters per second plus 25 kilogram meters per second equals 200 x kilogram meters per second. So then I divided that and got 0.125 meters per second as the velocity.